All right, let's dive into something truly mind-bending today. We're going to shrink ourselves down, way, way down, to a world so small it seems to break all the rules of reality. We are talking about nanotechnology, a field where the tiniest things are making the biggest, most world-changing impact. But to really get what's going on, let's kick things off with a little mystery. You know what gold looks like, right? I mean, it's gold-colored, simple. But what if I told you that if you take a piece of gold and shrink it down to the nanoscale, it's not gold anymore? Now, it turns a brilliant, deep ruby red. How on earth is that possible? And this isn't just some weird party trick you can do with golds. Oh no. The rules get completely rewritten for almost everything at this tiny scale. Take carbon, for instance. We know it as, brittle stuff like graphite in a pencil. But at the nanoscale, it becomes graphene, literally the strongest material known to science. So clearly something fundamental, something really profound is changing. To solve this mystery, we basically have to throw out the old rulebook, the one we're all used to, and crack open a brand new one. So welcome to the quantum rulebook. This is the physics of a world where, well, just about everything we think we know gets turned completely upside down.
Here's the absolute truth of it all. When you get down to the nanoscale, we're talking a few billionths of a meter. The normal, classical rules of physics just stop working. Atoms don't act like tiny little billiard balls anymore. Instead, they start showing properties of waves. And that, right there, is when things get really weird. And all that weirdness, it's governed by something called quantum physics. This is the set of laws that totally takes over at this unbelievably small scale. It's the reason for all these bizarre changes we're seeing. It's not magic, it's just a totally different kind of science.
And this quote right here really gets to the heart of it. See, nanotechnology isn't just about making tiny little gears or robots. It's actually about reaching in and directly messing with the quantum properties of matter itself. We're not just changing the size of something, we are changing its fundamental nature. Okay, so we know what's in charge now. It's quantum physics. But how does it actually turn gold into red? Let's peel back that final layer of the mystery. We are about to uncover the real secret behind all this magic. It really all boils down to the electrons. In a big chunk of gold, the electrons are just roaming around freely, doing their thing. But when you shrink that material down to just a few atoms wide, those same electrons start to feel, well, a little claustrophobic. They get trapped in quantum dot. This is the key. These tiny nanoparticles act like little quantum boxes. By trapping the electrons, you limit the energy levels they can have, and that changes which colors of light they absorb and which ones they reflect back to our eyes. So by perfectly controlling the size of the box, we can literally tune the color. And for gold, that perfect size just happens to reflect a brilliant red light. So the whole process is kind of beautiful in its simplicity, right? You start with a totally normal material, you shrink it way down to the nanoscale, and bam, its electrons are forced to play by quantum rules inside these tiny prisons. And just like that, you've engineered a completely new material with these incredible brand new properties. So now that we get the how, let's talk about the why this matters. Because this isn't just a cool science experiment locked away in a lab. This tiny, tiny tech is already having a massive, and I mean massive, impact on the world all around us. And these aren't just ideas for the future. These applications are here right now. Quantum dots are what make our TV screens and LEDs so much brighter and more energy efficient. In medicine, we can engineer nanoparticles to hunt down and destroy cancer cells without harming healthy tissue. And in tech, they're paving the way for way faster computer chips and solar cells that are way more efficient. And it's not just about color, not by a long shot. Let's talk about strength. The difference between normal carbon and its nano version, graphene, is it's staggering. We're talking about a material that's 200 times stronger than steel, but it's also unbelievably lightweight. That is the kind of power we can unlock from the quantum realm. So in the end, it really all comes down to this simple but incredibly powerful idea. By controlling matter at the smallest scale imaginable, we unlock possibilities that are just enormous. We're not just making things smaller, we are making them fundamentally better. Which, of course, leaves us with a really fascinating question to think about. We've seen how these quantum rules can change a material's color and its strength. What other fundamental properties are just sitting there waiting for us to unlock them? What's the next big thing? that's going to come from something incredibly, incredibly small.